Since the earliest moments of civilization, the process of discovery has driven all human progress. Knowledge builds upon knowledge to increase the pace of discovery. Scientific, creative, and commercial breakthroughs are the product of a global learning process that combines new experiences and interactions with the learnings we have gained from the past. Discovery then leads to automation, from manufacturing to healthcare to transportation to communication. Well-understood discoveries have been automated, computerized, revolutionizing every aspect of how we live our lives. Once a task is automated, we can stop thinking about it, freeing us to make new discoveries and accelerating ever so slightly the slow, human-bound discovery process. What if we could automate discovery itself? Self-discovering computers can fundamentally improve our way of life by solving hard problems we have been struggling with for decades. Cancer and disease will be a thing of the past. Energy will be abundant and clean. Agriculture will be revolutionized. Computers will even be able to discover entirely new fields of math and science, taking us beyond what we are able to imagine today. When imagining the future, it is always helpful to look back. Biological evolution, the original discovery mechanism, takes millions of years to discover new, useful abilities and adapt the genetic code to take advantage of them. The human mind accelerates that process tremendously. We invented language as a way to communicate ideas, and writing as a way to preserve them for future generations. We invented computers and data storage systems and the internet to further accelerate the process of remembering and sharing ideas. But still, only a few people from each generation truly advance humanity by generating new ideas and discoveries, ultimately becoming the bottleneck in our quest to fully understand the natural world. This is why AI is so exciting. What if we could recreate the entire history of human discovery in a machine? What if we could fast forward that process into the future and have these systems make discoveries, not every 30 years, but every 30 seconds?
Camera rolling.
See, Mark?
Hi, Max. You've been actively involved in AI for some time now, and in your book, you also talk about how AI can change the future around climate and things like poverty and healthcare. How do you see AI and its role in changing our future?
This is a really exciting time. You know, people have realized for basically as long as they've walked the earth, right, that intelligence has been the key to shaping our own destiny. And for most of human history, we were just running around trying to not starve to death and not get eaten, basically. And then gradually, because of science and tech, the things we were able to figure out with our intelligence, we were able to become more and more masters of our own destiny. We've more than doubled our life expectancy because of human intelligence. But there's still a lot of problems that we're still stumped by. So to me, it's incredibly exciting, this possibility that we might be able to amplify our intelligence with artificial intelligence and solve all those other problems too. You mentioned healthcare. Obviously, if we're told that a loved one has an uncurable cancer, it's not true that it's uncurable. It just means we haven't had the intelligence yet to figure out how to cure it. Of course, it's physically possible to solve our climate challenge and lift everybody out of poverty and do so many other things people have dreamt about. So this is a super exciting time, and not just because it's theoretically possible, but because it's really happening. The progress in just the last few years has been breathtaking.
You're a physicist. Do you think we understand the physics of the human brain? Do we have the tools that allow us to see everything that's in there? Or is there something in it, maybe quantum mechanical, maybe otherwise, that we can't really see?
Oh, that's a great question. I'm actually both a physicist and also an AI researcher, since that's what I've spent my last 7 years working on with my MIT groups. I think it's pretty clear that you do not need any quantum effects to build superhuman AI. There's nothing quantum at all about GPT-4, and there's no indication that our neurons in our head critically use quantum effects either that it's necessary for you to be so smart. There's this idea of substrate independence, which is very powerful, which in plain English just means that intelligence is all about information processing. It's not something mysterious intelligence that can only exist inside of human brains. It doesn't matter whether the information is processed by a carbon atom in a neuron in a brain or by a silicon atom in some sort of other device. It's the structure of the information processing that matters, nothing else. And that means that we've repeatedly been able to completely swap out the hardware. Now it's CPUs, now it's GPUs, now it's this kind of memory, now it's a hard drive with magnetism, and now it's flash RAM. From the perspective of the programmer, you don't even care.
Yes.
Right? It's as long as the information processing is the same. So you can actually abstract away a lot of the physics.
Yes.
That's the beauty of it, right? Which means that there is a real hope for understanding intelligence quite deeply, even without understanding exactly why we have so many different kinds of neurons in our head and so on, because that's just part of the substrate. One of the reasons why AI has advanced so fast recently, of course, has been that we have so much more data now to train our models on. I'm curious, can you say a little bit more about what you're doing now with various customers on the AI side?